Hello, everyone, and welcome to today's webinar. Why is this customer high risk? How explainable predictive decisioning can help us trust our AI models. I'm your host, Liva Randrabason, and on behalf of IIBA, thanks for joining us today. Today's webinar is a public event. It is designed to deliver practical resources for you as you continue to grow your skill set and deliver value within your organization. When you join IIBA, you become a member of an international association dedicated to developing and promoting the business analysis profession. Your IIBA membership gives you access to a vibrant business analysis community and resources to support your development and career growth. IIBA is a nonprofit professional association serving the growing field of business analysis. And our goal is to unite a community of professionals to create better business outcomes. As the global thought leader and voice of the business analysis community, IIBA works to maintain global standards for the ongoing development of the practice and certifications. And today's webinar is brought to you by Red Hat. Red Hat is a leading provider of open source enterprise IT solutions. We would like to thank Red Hat for supporting the business analysis community. We have two presenters today. Matteo Mortari is a software engineer at Red Hat, where he contributes in rules development and support for the DMN standard. Matteo graduated from engineering with focus on enterprise systems with a thesis involving rules engines, which sparked his interest and influenced his professional career since. He believes there is a whole new range of unexplored applications for expert systems within the corporate business. Daniele Zonca is the architect of Red Hat Decision Manager and Trustee AI initiatives, where he contributes to open source projects, rules, and Cogito, focusing in particular on predictive model, runtime support, and machine learning explainability, runtime tracing, and decision monitoring. And before that, he led the big data development team in one of the major European banks designing and implementing analytical engines. Welcome, Daniele and Matteo.
Hi.
Hi, everyone. Thank you for having us today. Let me share my screen.
Okay, let's start with the talk of today. So our goal today is present how we can improve the trust in our AI models and in our AI system in general using predictive decision. Let's start with a step back and try to define what AI is, because AI is definitely a hot topic, but there is a lot of different definition. So we can talk about AI and maybe you are referring to something. So let's try to define what we are, why, let's say, how we intend AI in this case. The pure AI definition, that it's the more traditional one, is intended, it's just the achievement to try to replace entirely the human with a machine. And this actually is quite far from now. So the reality is that pure AI, it's not really a target that we can achieve soon. So next slide. Okay, so let's try to introduce another type of AI. So the pragmatic AI. Pragmatic AI is, let's say, the scope of AI that we aim to target in this presentation and in general in business automation with Red Hat Business Automation Solution. So the idea is that we have a different building block technology: digital decisioning, mathematical optimization, natural language processing, machine learning, robotics, and many other that are intended to solve specific aspects of the problem. So provide specific AI capabilities, and then you can compose to solve your end-to-end business problem. Said in a different way, the goal of predictive decision automation is to combine machine learning, digital decision, and mathematical optimization to provide a pragmatic AI solution. What in this case, so you can focus to solve, let's say, specific aspect of your problem, considering the type of technology that you have. So we have machine learning that it's really a good tool if you needed to extract information from data. So you have your data that could be streaming data, batch data. So you have your data that come from customer behavior and similar, and you can use them to extract relations that are hardly to be defined manually, or that are almost impossible to define, let's say, upfront. So maybe you don't know exactly all the behavior that your customer has, and let's assume that we are implementing an e-commerce. So we wanted to implement a recommender to improve our to upsell, so to provide to suggest to our customer product that they could be interested in. So with machine learning, we can understand the similitude. We can, let's say, try to compare different customer behavior to try to see the similarities of each of them. So we can understand and group, classify our customer based on the behavior, and at that point compare this, the product set that each of the customer has, to see to compare it to the, let's say, to the cluster, so to compare it to the other similar customer, and provide a new product. After that, we can also, usually we need to also apply some digital decisioning. So we have some rules that are defined upfront from the domain expert. If you think about an e-commerce, I can try to clean up this suggestion list, because in a plain suggestion list, for example, it could be possible that I'm proposing a product that the customer already bought in the past. This is quite common, even if with, let's say, famous engine, like if you think about really the most popular e-commerce in the market, if you look for a tablet and then you buy it, it's for like at least one week or maybe more in the after the platform is still trying to sell you a tablet, because now you have been classified, because you searched for that. So now you are being classified in this way. While with digital decisioning, it could be easier to clean up and simplify this kind of constraint. Or even more, you can have let's say, change the priority based on business need. So if I wanted to push a specific product, even if it's not the best match, I can try to change the order because I really wanted to push on that direction. Or if you consider regulatory constraint, it could be possible that you needed to define, you need to be sure that, for example, you are using the information that in a way that is compliant with privacy law and similar. Then mathematical optimization, it's a natural addition, because when you close the deal, so when the customer bought something, you need to ship it and optimize. So by routing problems, optimize your shipping process in a way that it's effective from customer perspective. So I obtain my new phone, my new tablet in like in 1 day, in 2 days, but at the same time, I'm optimizing my shipping team in a way that I'm not wasting money. If you compose all of that, we can really have a pragmatic AI solution. Red Hat, it's based on open source, and it's also based on open standard. So in business automation area, many standards have been defined over a year, and we are contributing to define some of them to try to cover, let's say, try to help to shape and model the solution for this kind of problem. So if you look at the two different sides of this slide, we have business automation that is mainly targeting product line, business unit. So you have a business domain problem, and on the other side you have machine learning. And those kind of words are usually quite different, because on one side you have more an algorithmic point of view, while on the other side you have more a business point of view. If you look at the standard that has been defined, you have a CMMM to define a case, BPMN2 to define a process, and then you can also have DMM and TMML that are the focus of this presentation, that are two different standards that can be used to model a decision, so model a digital decision. Could be a decision table, could be, you can compose, so you can define, essentially you have the freedom to define your decision logic in a way that is user-friendly and high level, so that it should be easy for someone that knows the domain to model it. And on the other side, we have PML, that is a format tool for ML serialization. So the idea is that you have your algorithm, it's serialized, and those two standards can communicate and easily be integrated to provide an output that it's based on the digital decision enriched with ML logic. If we want to, let's say, analyze if we focus now on DMN and PML, so digital decisioning and machine learning, we have as I already said, we have two different type of persona. We have a decision modeler, that is someone that knows the domain logic, but is not usually doesn't have a mathematical background, so it doesn't have the capability to train an ML algorithm while it would like to use it, because definitely we have a lot of information that are sort of hidden inside the data that the company already has, and we wanted to extract all this value. The data scientist, on the other hand, has a different toolkit. So usually they use R, Python. They have a lot of different toolkit and different type of different way to work, and they would like just to communicate with a setup that it's reasonable, so it's understandable from a decision modeler, and it's also a good fit for the data scientist. PML, it's a standard that covers a lot of different type of models. At the moment, 19 different models: scorecard, neural network, regression, random forest, and many others. So the idea is that PML could be used as interchange format together with DMN to make those two different personas interact. This type of approach, even if now, starting from the next slide, Matteo is going to introduce a use case and show in details how we can actually use it in practice, our tool, to provide a similar solution. The reality is that it's a quite general way. It's a pattern that you can apply to many different business problems. So the fact that you have a constraint or rules or decision that are defined up front, and that you have information that you wanted to extract from data, and you want to mix them to enrich your decision logic, can be applied to really essentially a lot of different business use cases. If you think about efficient customer service management, so define and apply the next best action, predictive customer retention, so churn analysis, to try to recognize when a customer is going to leave, or this guy is going to sell maybe one, or to not use anymore one of my products, so try to prevent a similar or my service, and try to prevent this behavior. Upsell, fraud detection, customer loyalty scoring, optimize the workforce management, personalized experience. So the idea is that now we will start to introduce a real world scenario, a real world use case, but the same approach, the same pattern can be applied to almost any type of business. Okay, Matteo, please go on with the demo.
Thank you, Daniele, for this introduction. And indeed, now through the demo, we will see how we will make pragmatic use of what we've seen, and pragmatic use actually implement and deploy pragmatic AI. Before going into that, let's just also try to give a perspective for the business analyst out there and how they interact with the data analyst or data scientist. We like to think about this as two flows of interaction that are happening in the business right now, in any business actually that wants to adopt this solution. One is the decision automation flow, the one that you see on the right. It's basically start with business data. This represents your input. So I don't know, a prospect coming for asking for a loan, or a new client approaching, or like in the case of e-commerce, somebody that wants to buy something, or it's an order that already emitted. And then we will have some decision models that we will have described using an open standard. And we will use this decision model in order to formalize and actually execute some business relevant outcomes, some business relevant results that you would like to see, some business actions. This business action in turn will generate again some new data, customer coming back, and so on. And this flow is a flow that repeats. This flow of decision automation, it's really orthogonal to the machine learning and knowledge discovery that you do really as a machine learning flow. You still start with some inputs data. This can be structured document, like in the case of the business of e-commerce, can be the order submitted, or can be also unstructured for any reason, some audio, locations, or images, sounds, And the role of machine learning is really to produce a predictive model that will be able, based on new data in the future, to make a prediction about this information. So what is important to notice is that the predictive model can integrate with the decision model. We're going to see that in the demo today. And actually, we can use it to best integrate and augment itself with the decision modeling. So also the result of a predictive model, after a while, maybe we will need to retrain the model. So normally data analysts or data scientists might need to perform these operations. So that's why you see the feedback loop also for the machine learning activity. And this is what is going to happen. So we will see the intersection between a decision model and a predictive model that we're going to express with PMML. Before jumping right into the demo that will be also supporting the rest of the presentation today, I would like to give you some brief introduction about what we're going to see. The use case is about a credit card dispute. So a customer of a bank will not recognize some transaction in its credit card history and will file a dispute claim. When filing a dispute claim, behind the scene, the bank, the institute, have described with a BPMN2 diagram and extension how it would like to handle the case. It starts here, where the claim dispute is being entered, and immediately we will need to have a task that will decide if we want to automatically process this dispute, this case, or to process it manually. So in the case that we have an automatic processing, this is a very lean sub-process. But in the case of a manual operation, a manual investigation is required, it will be a longer process that actually also involves some actor, some human actor in the process, and so it will be very more longer, more efforts will be required to follow this process. What is important to see in this is that we started to get an idea how the business have formalized from the business requirement how they would like to support the process in action, in this case with BPMN. Then we will see how the bank in a first iteration will have described how to evaluate the risk for the current customer with a very traditional, I would say, analytic way by means of decision table. So decision table should be very known to everyone, but just to have a common ground throughout this presentation, we have these formalisms where we will have some input column and an output result of the evaluation. So let's say one example for the dispute risk. In this case, if I am a standard customer for the bank and I have disputed for less than $25, then my dispute risk will be very low. 1. In case that instead I'm still a standard customer for the institute, but I have disputed, let's say, $100, then my intrinsic risk for this transaction will be higher, S3. So this will be the first iteration of the demo. But we can do better. In 2020, we can actually use really machine learning and data science in order to better have an estimation of the risk, because we are the bank, we are the institute, so we own the data. So what we can do is that we can use the machine learning process flow, as we described. So the data scientists can use business data, structured and unstructured document, and thanks to machine learning, have a predictive model that will be much more efficient in describing and analyzing the risk for any future transaction. What is important to notice here, and I would like to have this really as one of the key takeaway, is that we are not going to promote, we are not promoting for doing machine learning or data science or data analysis in a different way. What we are promoting is that please use the same tools that you are used to. Here we've taken logos of a few of the most common for data science and machine learning, which is R, TensorFlow, Spark, any Python framework of your choice, but really any data analysis that supports machine learning can do, as long as we are asking what we are trying to promote is that instead of serializing the predictive model, so the result of this activity, instead of serializing it in a proprietary format or in a closed format, let's save it in an open standard such as PMML. Because if we save it the same result, which is the predictive model, in an open standard, then we can indeed integrate it in a platform that supports all these open standards that we are discussing in a very efficient way and in a very open way. So let's see that in action. I will have this demo that I'm going to comment for you. And so let's put ourselves in the shoes of the user of the bank. So we said it's a credit card dispute. I'm the user of the bank. I've connected to the bank portal. I can see my status. I'm a platinum member. I can see my total balance. And then I'm investigating the transaction history of my credit card. And yeah, I noticed that something here is not going right. And basically, I want to dispute this transaction because I don't recognize the amount. So I will follow the process that the bank have outlined, and I will follow the guided procedure that is really described through the business process of the bank. So I will enter all the required data, and we will see that a use case ID has been assigned to my case, in this case, ID number 4. So a very small example, but we can see now what is going on behind the scene and how this bank portal it's working, defined thanks to the business process. Here we're connecting on the OpenShift container platform to Business Central, which is the way that our platform support the definition of business process, decision models, and so on. And we are seeing that really it's this process that we briefly introduced earlier that is supporting that application. So we are going to see it in a bit more detail now. So it started the process. We know that we're going to have some decision task immediately. And the first key operation that the stakeholder of the bank have told the business analyst is that, okay, I want to formalize here that I will have a decision to take. And based on the outcome of that decision, I will decide if to have a sub-process to process it automatically, a very lean sub-process, or I will need to process this dispute manually. And in the case, I will need to send some email, start some chargeback, involve some human actor operators, some back office clerks, and then I will have different outcomes. Let's see in details what has happened to the dispute that we just did, the ID number 4. So we will see first, so this is the case instance that we've triggered as we use the bank portal of the bank. And now in the gray color, you see the path that we've taken. So the process started as soon as we submitted all the required data. Some decision tasks have been triggered. We're going to see what's behind that. And then the sub-process for automatic processing has been completed. So now we can dig a bit more and understand how we did this process. We will see that here we have all the data that are collected either automatically or manually throughout the application form. So I was a platinum user, and I can see the transaction amount that have been disputed, and we can start to see some risk rating really implemented here. In this case, very low for a value of 1. And these are risk rating that I even feel so are part of the decision activity. And those are supporting the final decision, which is if to process automatically or manually. And in this case, we process it automatically. So in the case, it's at the true. So we need now to understand how do we come up with this decision. And we're going to see that because now we are going to switch to the decision models defined with the DMN standard. So on this platform, we can navigate to the several assets that are supporting this business process definition. In this case, it's a decision model. We don't have time to go into the full detail on how DMN works, but it's basically trying with this graph to describe what is the outcome, the decision that you want to do. And in this case, the final outcome is process automatically or not, but you need to have 2 sub-supporting decisions to the dispute risk rating evaluation and the cardholder risk rating. And let's see what's behind that. These are the decision table that we briefly introduced earlier. So in the case that I've just played is that I'm a platinum member of the bank. I disputed for less than $100. And this is the reason why the dispute risk itself has been evaluated as 1. So it's a very low. So these start to show how really the decision management part comes into play with the process management activity. And then we will see that finally, this is the key policy of the bank. It's describing okay, here is a limited example, but it's describing that as long as the risks are below a certain threshold, in this case 5, then we will process automatically this transaction. So similarly, you can have even more elaborate policies, but here is the key point. We have implemented with the decision model a policy for the business stakeholder. Now we're going to see how we can actually integrate predictive machine learning models instead of having decision table as an analytic decision for the support. So what we do is that we will have our data scientists, our data analysts that have come up with a predictive model from machine learning, and we've asked them to serialize it with PMML, an open standard. Due to the time for this demo, we cannot show in the different tools like RStudio or Python how do you serialize a model with PMML, but basically it's a file. It's another file that you can upload on the Business Central management platform. And once we have uploaded these assets onto our platform, then we have the power to actually query this predictive model with the real case, with the in production use. So we have the model available for describing the dispute risk and the customer risk in a predictive model. And now we want to integrate it in the DMN open standard. We are providing the tool that helps you actually integrating these two standards together in the way that they are meant to by the standard organization, but we have an editor that it guides you to make the life a little bit easier. So in this case, I'm importing the dispute risk in a linear regression format. I've connected the two files together. So I've connected the decision model with the predictive model, and now I'm going to refactor this decision to make use of that predictive model from machine learning. So normally what I do in DMN is that I will use this type of nodes that enables you to evaluate functions like an external function, which could be the predictive model. So here I have several options available. I will select PMML open standard for predictive machine learning models. And it's asking me, okay, which predictive model would you like to query here? And then I will say, okay, I want this model, that is the one that I've imported earlier when I connected the two together. And then the tool, the editor here supports the business analyst because it guides to do introspection of the model, introspection of the file. So we can see that now I will be able to select, okay, what is the actual predictive model that is contained in that document. And as soon as I've selected it, it will prompt me automatically for the input parameters. So I don't need to be the data scientist just to understand how it's working internally, because I just want to know the surface of contact. In this case, I need to provide two inputs. So basically here, I just need to refactor this decision to pass in the input data, so the input parameters that I know of, that I already know, and I will just refactor to make use of this implementation. Now, for the purpose of, in the interest of time, like the best cooking show, I've already have another model here presented that already integrates the different machine learning model for the dispute risk of the transaction itself and the cardholder risk, so the evaluation of the customer risk. Both are done with predictive machine learning models that we connected to the PMML standard. So now what I can do is that in the system live, I can change how the business process management notation file connects to the decision models, and in turn use the predictive model of machine learning. So actually it's quite simple. So I just go here and I will say, okay, now I want to change the decision model, the DMN file that I will use to take this decision. So what is happening is that here I'll just change the file, basically to use the one from PMML that we briefly described. And as we've seen, it had the same structure, the same format. So the decision structure is basically the same, but instead it's using predictive machine learning models. So with the push of a button, you can redeploy live in production. This is done for the purpose of the demo. Normally in any, especially in Bank Institute, it's not like you can do it yourself. But here we can show how you can really use the platform to really affect the production immediately and see the changes. So now what we're going to do is that we switch again the hat, and we will put on our head the hat for the user. I connect again to my bank portal, and as we've seen, I'm a Platinum member, and I check my transaction card history. I will do the same dispute again on this demo system to show you what is going to change. The thing that will remain the same and the thing that will change. The procedure to dispute the transaction risk has been basically the same for the user point of view. It's always the same, and we will receive a new case ID. Case ID is number 5 now. Let's start to see what's been happening behind the scene though. So if what has been changed and what has not been changed. If I go to the process instance submenu, I can see the process instance and the case instance that have been triggered. And in this case, ID number 5 is the one that we just did. And yeah, we transacted it also automatically, this one, as we expected, because we entered the same data. But we see that the cardholder risk and the dispute risk are now different values. And those are not values that a business analyst would enter in a decision table normally. They are too much refined. So this is really where the predictive model has been starting into play. We get a different, slightly different result number from the one that we have from the decision table. But the key point here, it's one, is that the business stakeholder told us, as long as the risk rating is below a certain threshold, I want the transaction to be processed fully automatically. And here, because those two numbers when added are less than 5, then actually the result is the same from the user point of view and from the process point of view. So the transaction has been still processed automatically. So what we start to see is how really we can integrate predictive machine learning models with decision model and process model to have better outcome and more tailored outcome. Now, what we have as part of our platform is we have a technical capability for tracing and auditing that I will slightly skip through because my colleague Daniele will speak about a little later, and I will just focus on the dashboard that we can do for business KPI. So this is a dashboard that we built that targets all the business stakeholder and operational monitoring. What we have on the top area is a comparison of how many transactions are we processing automatically and how many manually. We're stimulating the system live with many data of dispute risk. What we want to use this operation dashboard for is that the business stakeholder at a high level want to check that the more we transact automatically, the better it is for the business, as we've seen. But also we can monitor how the dispute risk changes thanks to these heat maps that you see in the lower part of the dashboard. So the heat map shows the distribution of the value of the risk. So the dispute risk in this case is basically hovering between 1 and 2, and the cardholder risk rating, the one on the left, is hovering between 0 and 1, as we expect, because most of the cardholder risk, so the estimation of the customer's risk, is actually pretty low, because it means that as a business we have only the majority are good customer and not bad customer. But then now what we can see is that we can use an A/B testing setup to actually see how it changes if we use the decision model using decision tables or predictive machine learning. So once we've changed this is what would happen if we use the predictive machine learning for predicting the cardholder risk or the dispute risk. And we see that there has been a slight variation about how the dispute risk has been changing for that. And so maybe with the data analyst and the data scientist, we can revise it and check if we change the weight from, I don't know, a linear regression to a random forest, how the dispute risk again changes based on our live data. And so we can really describe this with our data scientists and our stakeholders to really make sure that we are running the predictive machine learning model with efficiency. So a small recap before I leave it to Daniele for going through better the predictive machine learning part. Just a small recap up to here. We've used beside of the process management notation file to describe the business process, we use a decision model. We describe it with the decision model and notation standard, DMN, to describe how we would take our business relevant decision, which is how to process this transaction. And we model it with the MN by the supporting decision, which are evaluation of the risk based on some inputs and some predictive models, which are made with PMML. And this is because these two standards are really have the capabilities, and especially the MN, to really integrate fully with an open standard such as PMML for machine learning predictive models. We also have the support of test scenario tooling in order to ensure that the business requirements are fully mapped for some example scenario or test scenario. So this is to ensure that however we are refactoring our process model, our decision models, we are still making sure that it fully follows some business requirement that we are given. So in this case here, we have a few scenarios that the business stakeholder are given to us and we implemented. Sometimes you want to check that given certain values, you are at an exact value or in a range of value. This is especially true with the predictive model that are more stochastic process. And then we've seen some business dashboard that we can use in order to monitor it from a high level point of view, but also how we can use it for really keeping under control the predictive model. The demo that you've seen flowing, it's fully supported on the Red Hat OpenShift container platform. We are using the Red Hat Process Automation Manager to manage the asset, BPMN, DMN, PMML, and those are executed still on the decision server, still of Red Hat Process Automation Manager. We also integrated with the Business Matrix with Prometheus and Grafana, and also the banking application is fully supported on OCP. And with that, I'll give the word back to Daniele, the stage back to Daniele for some more information.
Thanks, Matteo, for the demo. Really well done, as usual. Now we shown how, we introduced the concept of predictive AI, the pragmatic AI. We also introduced how we can, using open standard, to integrate AI, ML, and digital decision. But this is, isn't this enough if you have a system that is based on AI? Well, you can have also other aspects that you should consider, especially if you are thinking about to use it in production and actually apply those decisions to the end user. I will start with, let's say, with the news that came like a couple of weeks ago, as far as I remember. In this case, the output is quite funny. There was an AI-powered AI camera that tried to replace the human. So instead of having a human that have to move the camera, let's try to let's try to train a camera to automatically follow the ball. But then there was a ball referee, and the camera got confused. So the outcome was that if you was looking at the football match, the soccer match from home, you will see that the camera move out from the action and focusing on the referee, because probably during the training this kind of scenario wasn't tested. But of course, this is a sort of funny outcome of when AI goes wrong. But there are also other aspects to consider. In Europe, a couple of years ago has been introduced GDPR regulation that it's introducing a lot of privacy-related concern and aspects to consider, and actually a similar regulation has been applied also to other areas, not only in Europe. And can you move to the next slide, Matteo? Matteo, can you please move to that? Okay. And even if it's an high-level regulator, because it's applied to the whole European countries, and of course they cannot really detail, like if you use a neural network, you need to provide this information, or if you use a random forest, the user need to see the tree or something like that. But they are trying to impose or to start to introduce some concept like the meaningful information about the logic involved. So the real point is that even if the decision has been automatized, doesn't mean that the user has to accept it. So the end user can complain a human decision, and they should be able to challenge also an automatic decision. So it's not enough the fact that, yeah, it's the system that is providing this information. So a user can ask to have meaningful information, can also ask to have an explanation. So if I file a dispute and the dispute is rejected, and in case of challenge, the company have to provide those kind of information. It's not really completely clear what does it mean from a technical aspect, because it's probably the first step in this journey in terms of try to define the right, let's say, the right of explanation. But it's still the first step in the direction of let's say, try to define a perimeter about how to use AI and how to use ML, especially when this is applied to end users, when the output is applied to end user. Considering those kind of aspects, in Red Hat we created this Trust AI initiative, that is an initiative related to business automation solution that try to address some of those concerns and provide value-added services to a business automation solution to enrich runtime monitoring service that provide tracing and accountability service. So provide capabilities like if I have a dispute, I need to be able to come back to my decision and see all the intermediate steps, so understand all the logic that has been applied, so that I can at least, even for an audit perspective, I can at least check what's going on. And also an explainable service, because including ML and in general, when you have a black box model, so when you apply a model that it's really, let's say, not clear in terms of internal mechanism. Like if you think about a neural network, it's probably the best example. The neural network produces an output, but it's really hard to understand why or the internal logic. So explainable AI algorithms try to enrich the output and not only provide the decision output, but also information to try to understand why this decision has been made. Let's introduce also Cogito. Cogito, the platform that Matteo shown, it's based on technology that has been created in the last 5 to 10 years. So they are it's mainly a monolithic approach, while now a lot of applications are required to run on cloud in a way that it's easy to scale, that can scale horizontally, that has an optimized memory occupation, that it's microservice oriented. So the paradigm is changing. So with Cogito initiative, we are trying to adapt and evolve the technology and the algorithms that are battle tested, because actually they are running production, they are solving enterprise grade business problem, to leverage new technology like Quarkus, Spring Boot, Kafka, and OpenShift as a backbone to run all our microservices. I introduced Cogito because in a microservice-oriented approach, this is, let's say, a sort of picture from an architectural perspective about how a Cogito application is done. And you can see that the core is, of course, it's your own application with your own logic. So you have your decision, you have your process, and that is executed. But then, considering that now this system is split in multiple microservices, we have a lot of additional services that provide the other capability that you need to execute and to keep control of what's going on. For example, you have the job service if you have to schedule, for example, a timeout. You have your process that where a task need to be completed like within 1 day, and you can schedule a similar timeout. Trusted capability are a subset of them. So trusted service are monitoring and dashboarding, trusted service and explainability service are a subset of capability that are part of the Cogito ecosystem. So in your ecosystem, you can decide when you deploy, let's say, when you are happy with the logic that you have and you want, okay, let's move in production, you have the flexibility to decide which capability do you want. Another real important aspect that we are considering during the Trust initiative and considering the concern, so monitoring, tracing, and explainability, it's the fact that we have a different type of persona that interact with a similar system, with a different skill set, and with a different way or different expectation. So we have, for example, the case worker that usually it's interacting with the end user. So he has a quite good knowledge from a domain perspective, case by case. So he knows how to create a credit card request case, but usually has no or few really limited technical knowledge. Then we have a compliance worker or a bank manager, so someone that has a good high-level domain knowledge. So they know, for example, if it's a compliance worker, I know all the checkpoints that need to be applied before a loan to be approved, for example. So I have this kind of domain knowledge, but I don't have any technical knowledge, or in general, low technical knowledge. Then we have all the data scientists that usually has a low or limited domain knowledge, but they definitely have a good technical knowledge, so they can understand the internal mechanism of what's going on, while maybe they are not really able to understand the overall picture from a domain perspective. All those different personas has a different requirement, has a different need, and we wanted to provide the right tool to the right stakeholder. Business monitoring has been already introduced by Matteo. The evolution that we are progressing now is the fact that we don't want just to provide the tool to create a business monitoring, but we want actually to leverage the information that we have in the model, because the DMN it's a really clean way to define your decision logic. So we know, just looking at the model, the number of input that we have, the type of the input that we have, the number of decision. So why don't automatically provision a similar business monitoring? So we are using the same tool that Matteo was showing in the demo to automatically produce a dashboarding business oriented. So like the monitoring that Matteo shown, we will provide information like how many requests has been approved and how many requests have been rejected. So information that are useful from a business monitoring persona. In this case, could be someone, a compliance worker or a bank manager, that I want to see, for example, if I have a spike of requests that has been rejected. Those kind of information are easy to be understood using an aggregated visualization. The other side of the coin is the fact that a system needs to be healthy, and especially if it's a microservice system, you definitely need to monitor the system to be sure that everything is working well, because you have a lot of different components, so each of them can go up and going down. We can have a specific slowing down in the system for a specific service that could become a bottleneck. So it's important to keep track of those information. And even here, considering that Cogito provides information about number of endpoints that we generate, so number of services that we expose, we automatically produce a similar dashboarding with a focus here on the operational aspect. So number of requests, error code that can be returned. So the focus here is not understand if the output, so a system that is always rejecting a loan from an operational perspective is running fine. It's from a business perspective that probably is something you need to understand why, and you need to solve the situation. Both of these kind of monitoring tool are always based on the same flexible tool, Grafana, that we showed before. So we just provide a good default so that you don't need to manually create everything, but you can just definitely tune it based on your need. Let's introduce a simple use case to simplify the rest of the presentation, the webinar. Credit card approval. So here the use case is pretty simple, it's straightforward. We have a customer that is in front of the case worker and that is providing his own information, and the case worker interact with the backend, the system, the bank backend system. And one of the use case we want to cover is we want to help the case worker to explain to the customer why a credit card request has been rejected or accepted. Well, I expect that meaning that usually the customer wanted to know why is rejected, not why is accepted. But in general, we want to provide information to explain the decision itself. So the type of tool that for this type of persona, so no more high level. So I don't need aggregated information because I'm a case worker. I'm at, let's say, single case level. I have a single request. So I wanted to drill down to that specific request. I got this kind of information. We created this audit UI tool that give the user the possibility to see the output. In this case, you can see that the approved is false. So you can see that unfortunately the credit card cannot be approved. And the caseworker can not only see those information, but can also drill down to see the input specific for that specific decision, so and intermediate result. So it can drill down and know all the intermediate result that the system provides. But not only, another important key aspect that we want to cover is explainability. And here the type of explainability need to be good enough to, or I mean, simple enough for a caseworker to be understood. And here the type of, for example, explainable algorithm that we are using, it's a feature scoring. So we are trying to score each feature, each input that the user provides to understand the positive or negative contribution to the decision. So that I don't have only a black box system where, okay, those are my data and the output is false, but I can also understand that half of the input had a positive contribution to the decision and other had a negative. This information can be really useful also for the customer itself, because, okay, I realize that the credit card cannot be accepted because of this kind of characteristic. So even in case of dispute, so because again you have the right of to challenge the decision, you can discuss. You already have a better understanding. So maybe you can be considered. Let's say you can already accept the decision without the need to go in deeper and create a dispute that need to be processed. So the information that we can provide help all the stakeholders, because help the bank manager to the caseworker to understand what they can say back to the user, but also the end user to better understand the decision, and also to the auditor, because in general it could be possible that from an audit perspective, I wanted to realize if this specific decision was an outlier, because these kind of models, one of the tricky part of AI, of ML, is the fact that algorithms always provide a result. So if the training set, so the data that the algorithm used for trainings part are completely different to the real data that they will receive in production, the outcome could be really wrong or could be really bad from a business perspective. And those kind of information, understand if it's an outlier or not, it's another important information. So this kind of tool try to give all the information back so that I can keep control of my advanced AI system. As before the thanks, the final slide, let's give you a couple of resources link. You can find the video record, the demo that Matteo presented. You can have a better understanding. You can find the resources if you are interested to DMN. You can learn how to use DMN in 15 minutes, so it's a getting started guide. You can get more information about Cogito initiative if you are interested to the microservice approach. So if you have, if your company is, for example, performing a digital transformation, you maybe are interested to apply to use cloud-based, cloud-native technology, and Cogito could be a good fit. You have, you can read more an introduction to AI, or you can see a talk that we recently did to introduce and have a better understanding and also a more deeper understanding of the technology behind. And then, of course, you can get more information about Red Hat Business Process Automation, that is the products that Red Hat sell that aggregate all those open source technologies. And
thank you, Daniele, and also I seize the chance to thank all the attendees, and we really hope that with this presentation you can really take away with you how you can use open standards, really like a BPMN to describing a process, DMN to describe a decision model, and PMML to serialize a machine learning predictive model, and how you can integrate them together in order to support your business operation and your business decision. So we support it on the business Red Hat Process Automation Manager and Cogito platform, and also with the integration of Trust AI. And we really, again, thank you for your attention, and we are open. Liva, if there are any questions from the audience.
Thank you, Matteo. Thank you, Daniele. I think there was a lot of information that was shared, and I think there's a lot to digest as well. So one of the questions that we have here is, can I use DMN to formalize business requirements analysis?
Okay, so yeah, actually, I would strongly recommend to use it DMN. Likewise, you could also use a BPMN standard to really formalize the process. Maybe I can use actually some slides from the presentation of today to maybe describe it better what I mean. So normally, as a sort of like when the stakeholder comes and let's say that I'm the business analyst, I really need to formalize the process and the requirement that the stakeholder given to me. Then I can make use of open standards and indeed this visual notation. It helps in a first high level way, first of all, to describe how the process should operate, not only how it should be like, but actually how it will operate when put into production. So the good things about these standard BPMN and DMN is that they are visual notation. So I can use these sort of like to also have the initial engagement with the stakeholder when I'm defining the analysis part. And then I can start to plot it, use the tool maybe to sort of like as a sort of like a whiteboard to make sure that the requirements that are being captured are really implemented in the process, or eventually, let's say later for decision model in a DMN. So let's say that I use DMN in this case that I want to capture some requirement. In this case that we've seen throughout the demo, this part of the DMN standard, what is called the decision requirement graph, can be used, I think, really as a visual way, but also operationally to really capture what the stakeholder wants. The stakeholder told, okay, we need to implement a policy where we can do some procedure fully automatically as long as some threshold are not being exceeded, some threshold about a risk evaluation. So I can describe with the DMN standard which are the input data, the input values that I will use to make some calculation, and how they support some decision and eventually the final decision that the business wants. So I would totally recommend, maybe what you can do in a first stage is use DMN only as a visual aid, as a visual support, to start collecting during the requirement phase as a sort of like a visual paradigm to collect these requirements. And then the good things is that it's not only a visual standard. As we've seen, it can be used operationally. So as long as you define the DMN accordingly to the specification, you will have implemented, I don't know, in some other parts, you will have implemented other decision table for whatever reason. And then actually you can use it both to give it as a supporting tool, interacting with your stakeholders, but also to give it then to the IT, to the IS&T department, and to really deploy it immediately, because the model, as soon as it's defined, it's also executable. And same would apply for BPMN, for instance.
Great, thank you for this answer. Can the AI function identify new parameters that are not already included in the decision model?
Yeah, I think it's an interesting question, and I think it also depends case by case, because basically, let's say with the during the machine learning flow, you will be able to identify a predictive model, and you will extract some feature that indeed maybe you have not come up immediately thought that, okay, I needed this feature, it was so much relevant for predicting something. Then here, what will be is that the business analyst, while interacting with the data scientist or the analyst, it will receive the predictive model, and the predictive model, in this case, serialized PMML, will say, in order to make the prediction, I need this feature, so these are input parameters. And therefore, me as a business analyst now, I need to say, okay, in order to comply to use with that predictive model, I will need to incorporate some values, and then actually you can find it maybe as a process, as a BPMN process variable, and you can just add it, or maybe it's a symptom and it's an indicator that the business analysis need some little refactoring in order to include this in the new operation. So I think, yes, it's totally possible that this happens. I would say it's actually a good sign that could be a good sign that the machine learning activity has identified the new features. And so, however, the feature are still somehow coming from the business data, either structured document or unstructured. So from somewhere, this information, this input parameter have been extracted, and so it's like can totally be integrated when calling out to PMML.
Yeah, I think that in general, DMN is trying to map the whole decision logic, and it means that the stuff it's self-contained. It means that all the data need to be specified, but this is usually created after the creation of the model. So when you create the creation of the ML model, so while you train your ML model, it could definitely be possible that there are derived feature that actually it's computed automatically by the system based on data that they already know, or it could be possible that we decided to integrate. So if the idea, for example, is that the user just provide the name, and then the name is used to fetch and collect other data that all are used, yes, definitely you can do. And this is definitely a benefit from the fact that you can also integrate with the process, because as part of the process, you can retrieve additional information that can be used for the decision logic. So you are not limited to the data that the user directly provide. You can have another step where you can enrich the information. Then you can have a proper decision execution, and this decision execution can of course invoke the ML algorithm.
Thank you both for this comprehensive answer, and it's actually the last question of today's webinar. Again, Matteo and Daniele, thank you so much for sharing your knowledge. Really appreciate it. And everyone, thank you so much for participating in today's webinar. Have a good day. Have a good afternoon, evening, rest of the day, wherever you are. Thank you.
Thank you. Bye.
Bye.